Hello all, I am Professor Snehal Shinde from JSPN Marie Technical Campus. Today we are going to study the subject Computer Graphics. And from this subject we are going to see some of the topics from Unit 5, that is Shading and Hidden Surfaces. So in this session we are going to discuss following points, that is basic concepts of scanline algorithm, then span coherence, overview of scanline algorithm, then inside or outside span determination, parity check, data structures used, and an example of scanline algorithm. Now, to start with the scanline algorithm, it uses an image space method. As discussed in the earlier sessions, we have seen that if we want to detect the visual surface, we have two approaches available, that is object space method and the image space method. So this algorithm uses image space method, where it deals with the projected image, or at the pixel level calculations are done over here. It is an extension of scanline algorithm for filling polygon interiors. We have already seen in second unit that the scanline algorithm is used for polygon filling, where we have seen different data structures, that is it uses active edge table, global edge table, and we have seen that algorithm, how it uses scan lines to fill the area between the polygon, fill area with color. Okay. So we can say that this is an extension to that scanline algorithm, because most of the methods are used here also while detecting the hidden surfaces. Now it is used on scanline coherence across multiple scan lines, or span coherence. Or we can say in the first session where we have seen the visible surface detection, we have seen the span coherence. We can say that the scanline algorithm uses either span coherence, or we can say it uses area coherences also. So we know that the span is a group of adjacent pixels lying on the scan line. Okay. Now we will consider this diagram. Okay. Here I have shown the two polygons, say polygon A and polygon B. Now we can see that polygon B is overlapping polygon A, or it is occluding polygon A, because some portion of this polygon A, where this I have shown with the dotted line, it is hidden by this polygon B. Okay. Now we will see some of the terms that we are going to use in this scanline algorithm. Okay. And those terms are, say, inside span or outside span, then again inside span in multiple polygons. Okay. Now here with the red lines, these are the scan lines. These horizontal lines are, suppose this is the first scan line, second scan line, and the third scan line. Okay. Now if I consider first scan line, it is intersecting these two polygons, polygon A and polygon. So this area which is inside of the polygon. Okay, so from here you can check my pointer. From this portion to this portion, this area is of polygon B. Again, this portion on the scan line is of polygon A. So I can say that the span of this scan line 1 is, this is for polygon A, and this span is of polygon B. So now it is inside, this span is inside polygon A, and this span is inside polygon B. So this is called as the inside span. It is contained in one polygon. This is contained in polygon B, and this span is contained in polygon A. Similarly, for scanline 2, this much portion, I can say this, it is contained in polygon B. So this span is contained in one polygon, and this portion, this is contained in polygon A. Similarly, for scanline 3, this portion is contained in polygon B, and this span is contained in polygon A. So these are called as the inside spans, which are inside one polygon only. Okay. Now, if you notice for this scanline 3, this particular portion is outside of the polygon area. Okay, so that's why this is called as the outside span, and this will not be visible on the screen. We know that this is not at all the part of the polygons, so we will not display it on the display screen. Okay, so this is called as the outside span. Now, if we notice the scanline 2, scanline 2 is intersecting both the polygons, and this particular portion I have shaded it. Okay, so this particular portion of the scan line 2, or we can say this particular span, is inside the polygon, but it is inside polygon A also and polygon B also. So we can say that this is the inside span, but in 2 polygons. Okay, so these terms we are going to use in our example or in further algorithm. That's why we have seen what is it called. Okay? Now, next. Before going to actual algorithm, we will just overview what actually this algorithm does. Okay, so this algorithm deals with more than one surfaces. Okay, so here, if there are overlapping polygons, we can solve it, or we can detect the hidden surfaces with the help of this scanline algorithm. Now, as each scan line is processed, this line will intersect many surfaces. Just now we have seen it. Okay, it will intersect the polygons. The intersecting line will determine which surface is visible. Depth calculation for each surface is done. The surface rear to view plane is defined, and when the visibility of a surface is determined, then the intensity value is entered into the refresh buffer. Okay, so in short, what we are doing, we are intersecting the polygon with the scan lines. Then we will from those scan lines we will detect which surfaces are visible, and or we can say which are the visible spans and invisible spans. Okay, and if suppose some spans are there that are contained in more than one polygons. Okay, so in that case we will use the Z buffer algorithm here. Okay, so we have seen that in previous session that Z buffer algorithm, what it does, it finds out the depth of the polygon, and whichever is nearer to you, you are highlighting those polygons. Okay, so here also the once you have decided that yes, this is the part of that polygon, then you will decide that the visibility of the surface is determined, the intensity value, it will be entered into the refresh buffer, and that polygon will be displayed. Okay? Again, this we will see with the example so that you will get a clear idea. Okay, now some terms we are going to use here. So if we want to determine inside or outside span, how we will determine it? Okay, we know that the scan line is subdivided into a sequence of spans. Each span can be either inside or outside polygon areas. Now, if it is outside, then no pixels need to be drawn because it is the background color. We have seen this in diagram here. This is the outside span, so we are not going to display this particular area. Okay, and inside means what? It can be inside either one or multiple polygons. So here this was inside one polygon and this span was inside 2 polygons. Okay, now if a span is inside one polygon only, the pixels in the span will be drawn with the color of that polygon. Okay, are you getting? So here, if I have determined that this particular span is contained in the polygon A only, I will shade this particular span with the color of the polygon A. Okay, so only this much part will be displayed as a part of polygon A. Similarly, if a span is inside more than one polygon, then what we have to do? Then we will compare the Z values of those polygons at the scan line edge intersection point to determine the color of the pixel. So as I told you that this span is contained in more than one polygons, that is it is contained in 2 polygons. Okay, so in this case we will find out the depth of the polygons. Okay, so in this case definitely this polygon B will be closer to the view plane, so we will color this particular span with the color of the polygon B, and then we will say that yes, this polygon B is occluding, or it is covering, or it is overlapping polygon A. Now, next term we are going to use is the parity check. To check whether the span is inside one or multiple polygons. So with this parity check, we are finding out whether the span is inside one or multiple polygons. When a scan line intersects an edge of a polygon for the first time, okay, scan line is intersecting a polygon, but when it is intersecting for the first time, the span becomes inside of polygon from that intersection point onwards. And when it intersects the same polygon for the second time, the span becomes outside of the polygon from that intersection point onwards. So this flag in or out for each polygon is used to keep track of current state. And initially the flag is set to outside, that is value is set to 0, and 1 if we set it to 1, then we can say that the span is inside. This actually, all these terms we need while we are going to implement it. Okay, so but just for understanding we are taking it. Now each polygon will have its own in or out flag, definitely. So there can be more than one polygon having in or out flag to be in at a given instance. So just we have seen that overlapping area where that span is contained in more than one polygons. Okay, so at that time scan line, so here this scan line is intersecting this polygon B also and polygon A also. So both of these polygons will be marked in at the same time. Okay, that is what we are saying here. So there can be more than one polygon having in or out flags to be in at a given instance. So if there are more than one polygon in, perform Z value comparison to determine the color of the scan lane. Now, while implementing this, these are following data structures we need to use. Again, we have seen this type of data structures in case of scanline polygon filling algorithm. Okay, we have seen the algorithm for scanline polygon filling. There also we had used this age table and the polygon table. Suppose this age table represented by ET and polygon represented by PT. Okay, so this contains, age table contains some values. That is, first is what? X value for the lowest y. Okay, we know that age means it has x1, y1, x2, y2, two coordinates it has. So whichever is the lowest y value, its corresponding x value will be stored here. Then its y maximum value from y1 and y2, whichever is the maximum, that y max value will be stored here. Then we know the delta x value is stored. Each polygon has its ID, so that polygon ID is stored into the age table, and this is the pointer. Okay, and similarly in polygon table also we will store the polygon ID, then some plain information, that is A, B, C, D values. We know that the surface equation, that is AX plus BY plus CZ plus D equal to 0. So this was the surface equation. So this ABCD coefficients are stored here. Then the color of the polygon is stored, and for which particular polygon, whether it is in or out, that flag is set here, and this is again the pointer. So along with this age table and the polygon table, we will use active in polygon list, that is IPL, active in polygon list. Okay, so here the polygons are marked in. Whichever polygons are marked as in, those will be stored. And active age table means currently your scan line is intersecting whichever ages. So that information is stored into the active age table, that is ages which are under process for a particular scan line. So we will see one example here. Okay. Now consider that this is the image. Again, the same image I have taken. The first polygon, this A, B, C, its vertices are A, B, and C, and this whole surface of this polygon ABC is called as S. Okay, and another polygon is there 1, 2, 3. These are the three coordinates 1, 2, and 3, and its surface is called as T. Okay, again this shaded portion, that means this 1, 2, 3 polygon is occluding polygon ABC, or we can say this 1, 2, 3 polygon is overlapping polygon ABC. Okay, so this much part of polygon ABC will not be visible. Okay, so suppose we have artificially defined some extent of the range of the scan line, that is x0 and xn. Okay, this is nothing but x0 and xn are the finite limited view of the display area. So your scan line will move from say x0 to xn. This is the horizontal extent we can say. This is the finite extent we have defined. So this is x0 and xn, or we can say x minimum, x maximum, like this. Okay. Now we will consider these scan lines. There are 4 scan lines are drawn. SL1, that is scan line 1, scan line 2, scan line 3, and scan line 4. And BG means this is the background color of this display area. Okay. Now we will maintain the table as first column will be for scan line. So scan line 1, 2, 3, 4. Second is just we said that active age table. This particular scan line is intersecting which ages at the current time. So those age information will be stored in this column. And this is the IPL, that is in parity list, the polygons which are marked as in for the particular scan line. Okay, so here this is the color that we are going to set. So we will see each scan line one by one here. Okay, now if I check first scan line 1, and we are going to check the intersections with this polygon ages. So my first scan line here, if I start from x0, so this scan line is intersecting initially age AB, and then here at the second point here it is intersecting the age BC. Okay, so rest it is not intersecting any of the polygon. So scan line 1 is intersecting 2 ages at a time. So what we have written here, scan line 1 started from x0, ended up to xn. So for each case we have written that is it is starting with x0 and ending with xn. So now first it intersected age AB or BA, whatever you can say, AB and BC. Okay, so these ages are intersected. Okay, next what we have done, I have written that in polygons. Okay, so BG. So what we will do here? Sorry. So initially, this much part from x0 to first intersection, this much part will be displayed with the background color. Okay. Then from this intersection onwards up to second intersection, we will color this polygon with the surface S color, right? Polygon S color. And again from this intersection point, this much part will be colored with the background color. So background, then background plus this S color, and then again background color. So that's what we have written here, background color initially, then the background will be overlapped with this S color, and then again the background color. Similarly for scan line 2 we will check. Okay, scan line 2, we are starting with x0. Initially it is intersecting age AB over here. Age AB is intersected here. So we can check x0, then AB or BA you can write. Next, it is intersecting at point this. So age BC is intersected with this scan line 2 here. Okay. So next is what? After AB, it is BC. Similarly, after BC, here it is intersecting the age of this polygon 1, 2, 3. That is 2, 3 age is intersected. Okay. So 2, 3. And after that, again, one more age is intersected, that is 1, 3 over here. Okay, so this scan line 2 is intersecting this polygon at 4 places, 1, 2, 3, and 4. Okay, so 2, 3, and 1, 3, and finally it is xn. So in this case, now what will happen? So first is background color, then this much portion is of polygon, this only, S only. So BG plus S. Similarly, here only BG, BG, BG plus BG. Next, after this polygon is, or this span is inside only one polygon, so that is T. So BG plus T, and again BG. So BG plus T and then BG. Okay. Similarly for scan line 3 we will check. So intersecting AB, then 2, 3, AB or BA, then 2, 3, then it is intersecting this AC and finally 1, 3. So AC and 1, 3. Okay. So here if we check scan line 3, This is the color background. Then this particular color is background plus S. Now this span, this overlapped span, this is contained in more than one polygon. Okay, so here we can write BG plus S plus T because both the colors are there available over here. Okay, so I have written here BG plus S, after that BG plus S plus T. This is the span where the span is contained in more than one polygon. After this, again BG plus T only. This is portion of only polygon T. Okay, so BG plus T and then BG. So BG plus T and then BG. And same case for scanline 4, that is intersecting the edge as AB, then AC, then 1, 2. So AB, AC, 1, 2, and finally 1, 3. So 1, 3 and XL. Okay, so this is scanline 4. And similarly for color, first the background color BG, then polygon S, so BG plus S, again background, this is outside region, so background, again this is only polygon T's area, so BG plus T and background. So BG, BG plus S, BG, BG plus T and then BG. So BG, BG plus S, BG, then BG plus T, BG. Okay, so in this way. And now for this particular area, our algorithm will work or will use the Z buffer algorithm so that it will find out the depth of the polygon S, similarly the depth of polygon D, and whichever is closer, then it will color the polygon with that particular polygon, either S or either D. And in our case, it will be polygon D because this is closer now. Okay, so that's all for this scanline algorithm. Thank you.